I'm Jennifer Sears, an engineer with the U.S. Army. I assume some of you may be familiar with engineering as an occupation, which was not the case a few years back when I spoke at my daughter's career day in Mrs. Weaver's kindergarten classroom. At that time, one of the students heard that I was an engineer and thought that I had the coolest job ever since I was able to drive trains. Well, no, my job is not as cool as driving trains, but it does have its perks. Engineering as an occupation is the application of scientific and mathematical principles to solve problems. In my case, I'm a biomedical engineer, which involves the application of these same principles to solve medical and human-related problems. I am only a Spartan by association. I grew up in New Lebanon, Ohio, but both my parents are Valley View graduates, and my two children attended Valley View Primary until about a year ago when I convinced my husband that it was the perfect time to move our family more than 9,000 miles away from home to Australia for a 3-year assignment as a civilian research director with the U.S. Army. It is here in Australia where I'm recording this video today. Don't get me wrong, it's been an amazing adventure, but like many of you, at the time I had no idea of the challenges that 2020 would bring. During the last year, my family has endured an international move, wildfire evacuations, a global pandemic, and international border closures. And those are just the major things. They don't include the small things like learning and remembering to drive on the left. Also, it's a bit disorienting to celebrate Halloween in the middle of spring and Christmas in the middle of the summertime. But this is supposed to be a career briefing, so getting us back on track, let me back up a few years and tell you about a few of the educational and career stops that brought me to this point. To be an engineer, you must complete a bachelor's degree, which typically takes 4 or 5 years. Engineering degrees can be quite versatile, so once completed, you do have a few options. First, you could enter the workforce as a design engineer and put your skills to work right away. Or you could pursue a law degree. Patent law, for instance, requires an undergraduate degree in a science and technology field. Or with a bachelor's degree in biomedical engineering, you could attend medical school. Another option is to attend graduate school in business. So you could achieve an MBA, for instance, so a Master's of Business Administration. This would allow you to work on the business or management side of a technology company. Or if you aspire to run your own company someday, a 2018 Harvard Business Review study found that about 1/3 of the top 100 CEOs at the time held undergraduate degrees in engineering, so that's always an option as well. Finally, you could pursue a graduate degree, so this would be a master's or a PhD in engineering. And so this is something you would do if you wanted to pursue a career in research or academia. And by academia, I mean be a college professor, for instance. So this is the route that I chose. And after completing my bachelor's degree in biomedical engineering at Wright State University, I applied for and received a fellowship to stay at Wright State and subsequently finished my master's in biomechanical engineering and my doctorate degree. A doctorate degree, or a PhD program in this case, is typically a 3 to 5 year commitment. And at the time that I began my program, I wanted to be a professor. So to borrow one of our favorite Aussie sayings, I gave teaching a go for a few years, but realized that it was not one of my strengths, at least at that point in my career. And I found myself in a role as a survivability engineer for a large defense contractor in Cincinnati. In this position, I built computer models of armored vehicles to evaluate the impact of the vehicle design on the risk of injury to the occupants during blast events. So this was predicting like broken legs or the risk of traumatic brain injury, for instance. These models were critical to the design of the vehicle because live fire testing of these systems is quite expensive, and we were able to evaluate different vehicle designs before conducting the field test. So after a few years in that role, I moved into a civilian research position with the Air Force Research Laboratory at Wright-Patterson in Dayton. So in this position, I led research programs to advance air medical evacuation practices. So air medical evacuation is the movement of injured warfighters out of a war zone. So as an example of the problem sets that we encountered in this job, Let's think about trying to provide the same level of care that you would provide in an ICU on the ground in the back of a C-17, which is a large cargo plane. If you've ever flown on a commercial flight, you've likely felt tired or had some mild physiological symptoms following the experience, so ear pressure, for example. This is due to the stresses of flight, which include changes in pressure, lower oxygen levels, changes in temperature, humidity, lighting, vibrations. So these stresses can negatively impact the physiology of healthy individuals, but they also create some very unique challenges for medical providers when they're caring for injured patients. So in addition to the physiological impacts, many pieces of medical equipment are designed for use in controlled environments on the ground. And they're also impacted by these flight stressors when used in flight. So the team that I led conducted research to inform both clinical care protocols and identify hardware and software modifications that may be needed to ensure the best outcome for the patient when treated in these environments. Following this role, I spent a few years working as a science and technology advisor and manager. Here I track technology trends to advise senior leaders on the art of the possible, and also served as a matchmaker of sorts between the Air Force's technical community and the operational community. This was my first experience as a supervisor, which I really enjoyed. And it's also during this role when I found my passion for working at the seams of various technical fields to bring people together with a common interest to solve complex problems and deliver new capability. In my current role as a research director for robotics, autonomy, and artificial intelligence with the U.S. Army's Combat Capabilities Development Command, I get to do just that. Specifically, this assignment affords me the opportunity to connect U.S. scientists and engineers with their counterparts in Australia and other partner nations throughout the Indo-Pacific that have an interest in solving similar problems. Plus, I get to learn about some really cool and innovative technologies along the way. While I'm not sure what opportunity will come next, it is my family's plan to return to the Valley View community at the completion of this assignment. But in the meantime, I'd like to leave you with one of my favorite quotes from Gloria Steinem. And it's that dreaming, after all, is a form of planning. So in closing, I wish you the very best as you think about your future career dreams. I will also share my email address in the event there are any follow-on questions about careers in biomedical engineering or DoD civilian positions in science and technology. Let's see here. And with that, I wish you all the best. Cheers.